Have you ever gazed up at the night sky and pondered, are we the only conscious beings looking back at the stars? Take a moment to reflect on this astonishing statistic. Astronomers estimate that there are approximately 100 billion planets in our Milky Way galaxy alone. However, throughout all of human history, we have only verified 2 interstellar visitors. But that number has just changed, and the ramifications are both terrifying and marvelous. We are currently monitoring an object, 3I Atlas, with data indicating it may not be a mere rock at all. Could this be the proof we've been searching for? We maintain vigilant observation of 3I Atlas, an interstellar object roughly equivalent in size to Manhattan. Initially thought to be a comet, it is now moving closer to Earth. You'll want to check out the latest images of this object, which seemingly has completely shed its tail. Some scientists are now proposing that this new information suggests 3I Atlas is not a comet, but rather an extraterrestrial spacecraft or a fragment of alien technology. The James Webb Space Telescope has once again transformed our perception of the universe when its sensors identified this interstellar object. Initially, astronomers anticipated it would resemble other known rogue objects, like Oumuamua and 2I Borisov, small fragments of ice or rock cast away from their parent star systems, adrift between stars. Yet, as Webb's infrared capabilities began capturing detailed spectra and images, the results uncovered something utterly unforeseen. 3I Atlas turned out to be much larger than anyone had predicted. What was once considered a minor interstellar traveler has revealed itself as a celestial body of such incredible size that it challenges our previous assumptions regarding how such entities could exist, let alone endure a turbulent transition from a planetary system into interstellar space. Stay tuned because what unfolds next will completely astonish you. If you're intrigued by the enigma of 3I Atlas and wish to explore more incredible cosmic narratives, hit that like button and signal to the universe that you are engaged. Each click assists in the pursuit of the unknown. Share your location in the comments. I'm eager to see from where in the world you are witnessing this discovery alongside me. Initial observations clarified as 3I Atlas sharpened through ground-based telescopes, particularly Webb's near-infrared camera. The object appeared as a faint speck a few miles wide, but deep infrared imaging unveiled a massive structure with peculiar heat reflections and emissions. Analyzing its brightness indicated that 3I Atlas was hundreds of miles larger, far exceeding any other recorded interstellar objects. This shocking finding is perplexing, as standard models suggest it's nearly impossible for such large bodies to be expelled from their stellar systems. Webb's spectroscopic data points to an alternative theory. 3I Atlas could be the core remnant of a demolished dwarf planet, carrying an uncommon combination of ices, silicates, metals, and organic molecules, reflecting a radiation-rich environment distinctly different from our solar system. Mid-infrared measurements are still detecting ammonia hydrates and carbon compounds, implying the object endured intense internal heating or tidal deformation. This evidence rules out the possibility of it being a primordial comet and bolsters the hypothesis that it is the remnant of a once geologically active world that drifted into interstellar space as a failed planet. If substantial chunks of matter can be ejected from stellar systems, then planetary formation models must also accommodate the chaotic interactions prevalent in youthful star clusters, the likely origin of 3I Atlas. This object could serve as a frozen remnant of a turbulent, early stellar nursery. Observations from Webb additionally revealed a thin crust ejecting material through ancient fissures. The rate of this ejection showcased that 3I Atlas undergoes a slow rotation cycle spanning several days, consistent with a monolithic structure adept enough to endure billions of years adrift in interstellar space. Consequently, 3I Atlas stands out as a striking example of the possibility that the universe houses countless planetary fossils, remnants of obliterated worlds still carrying the chemical signatures of distant star systems. If such colossal fragments are commonplace, the universe might be undergoing a silent interstellar flow, transporting complex matter to emerging protoplanetary disks. This could have significant ramifications for the development of atmospheres, planetary structures, and potentially the very precursors to life. Based on the data from Webb, simulations portray 3I Atlas as having a dense rocky core encased in ice and dust, resembling configurations seen on Europa or Enceladus. This opens up the possibility that the object may have originally belonged to a celestial body with a subsurface ocean. If true, interstellar space might be filled with the remnants of warm worlds that previously featured prebiotic chemical conditions. As 3I Atlas approached the Sun, Webb detected pronounced sublimation activity, including gas jets abundant in polycyclic aromatic hydrocarbons and nitriles, key precursors to amino acids. This marked the first detection of these compounds on an interstellar object, instantly igniting the debate over panspermia. Could life's building blocks journey across the galaxy through debris like Atlas? While it's improbable for 3I Atlas to harbor life at present, its possession of complex organic molecules renders the theory of biological precursors traversing through space fascinating. These clumps of matter, having floated for millions of years, could act as primordial vessels, quietly delivering the essential components of biology to any star system they encounter. For planetary scientists, the surface characteristics of 3I Atlas present an equally enthralling narrative. Smooth, bright areas interspersed with dark, heavily cratered regions indicate a storied history of past collisions and resurfacing, potentially occurring when the object still orbited its parent star. Some theorize that 3I Atlas was assaulted by a dense asteroid belt, or repeatedly bombarded by smaller moons and asteroids. The craters and fissures captured in Webb's infrared imaging depict a world ravaged by cosmic violence before being expelled from its stellar system. Additionally, Webb's spectroscopic data unveiled crystalline ice, material that forms only after prolonged cycles of heating and cooling. This finding suggests that 3I Atlas was exposed to relatively high temperatures during either internal heating or while orbiting its host star. Such evidence supports the notion that the object once belonged to a complex planetary system and might have existed in a region where liquid water was present. The immense size of 3I Atlas prompts inquiries into how many similar objects may be quietly drifting amongst the stars, possessing low light reflectivity and modest movement speeds against the backdrop of the universe. Most of these wanderers remain nearly invisible, only becoming detectable when near the solar system. The revelation of 3I Atlas hints that interstellar space is far from empty. It could instead serve as a repository for ancient debris from lost worlds generated by countless previous generations of stars. An increasing number of researchers label objects like 3I Atlas as wandering relics, structurally intact fragments of extinct planets that retain the chemical signatures of distant star systems. Each one is reminiscent of a sample collection mission from another region of the Milky Way, eliminating the need for human exploration beyond our solar system. Notably, the energy necessary to eject such an object from its parent star is extraordinary. Dynamical models suggest that an interaction with a gas giant alone wouldn't suffice. Rather, a binary star system may provide a sufficient gravitational nudge to dismantle the orbital structure, launching the object into interstellar space, a theory consistent with the unusually high velocity of 3I Atlas. Webb's ultra-high resolution made it possible to detect faint dust trails escaping from the object's surface. Optical analysis showed that these dust particles exhibit isotopic ratios markedly different from those found within our solar system, suggesting origins from a star with higher metallic content and a distinct oxygen-carbon isotopic ratio, making 3I Atlas a chemical messenger from another segment of the galaxy. If more interstellar objects are analyzed similarly, they could significantly aid in charting the chemical composition of the Milky Way from a fresh perspective. The discovery further emphasizes the astounding capabilities of the James Webb Space Telescope. Although primarily designed to delve into the primordial universe, Webb is proving its aptness to investigate our own cosmic backyard, where enigmatic objects like 3I Atlas linger in obscurity. Webb's infrared vision has transformed what was once a faint speck of light into one of the most significant interstellar discoveries of the decade, providing vivid insights into the chaos, evolution, and chemical diversity occurring on a galactic scale. The excitement surrounding 3I Atlas stems from its implications regarding the remarkable resilience of planetary matter, a body able to traverse interstellar space for millions of years, exposed to cosmic radiation and extremely low temperatures, while remaining mostly intact. This suggests that planetary systems possess the ability to create structures that endure beyond the life of their parent stars. The data collected by Webb offers a rare perspective on how interstellar matter interacts with sunlight, revealing sublimation rates, color alterations, and changes in reflectance spectra as 3I Atlas rotates. These variations render the object a living laboratory for directly studying the chemical evolution of planetary remnants from distant star systems. Beyond its scientific importance, 3I Atlas also carries profound philosophical implications, acting as a bridge between star systems and reminding us that planetary boundaries are not impermeable. Matter, and potentially life's precursors, are perpetually exchanged on a galactic scale. Each celestial body tells a story older than Earth itself, carrying traces of worlds that vanished before our Sun ignited. Webb's capacity to measure the dimensions and composition of 3I Atlas highlights the necessity for next-generation observatories. Future telescopes will be essential for tracking these rare interstellar visitors, thoroughly analyzing their compositions, and perhaps someday launching probes to rendezvous with them. Recent observations have unraveled an unexpectedly complex surface for 3I Atlas, with pockets of iron-rich silicates nestled next to frozen methane and a highly reflective stratum of infrared crystals. These indicators hint at a geologically active history, possibly involving tectonic movements or ice eruptions before being expelled from its parent star. This implies that planetary geology within the galaxy may be immensely more diverse than suggested by our solar system alone. For cosmochemists, 3I Atlas serves as a treasure trove of data. Isotopic variations across the object yield fresh insights into how stars synthesize and disseminate elements throughout space. Each signature present acts like a timestamp from another region of the galaxy, revealing a chemical chronicle that predates Earth's formation. The presence of 3I Atlas also highlights the limitations of human observation. An object hundreds of miles wide can navigate the stars, only becoming visible when approaching our solar system, thus emphasizing the galaxy's vastness and the multitude of worlds that may have formed and disappeared long before our time. Data from Webb further exhibited that 3I Atlas behaves unusually, retaining heat and releasing energy slowly and unevenly, indicative of a dense interior encompassing a rocky or metallic core enveloped in ice. Its spectra also recorded minerals that only materialize in environments characterized by liquid water or elevated temperatures, implying hydrothermal activity beneath its icy surface. The lingering question is how 3I Atlas has managed to remain intact amidst the punishing conditions of space for millions of years. Its self-protection mechanism might lie within its crust, influenced by cosmic rays. The ice layer undergoes continuous sublimation and refreezes, forming a self-regenerating shield that preserves the internal chemical structure. As a result, 3I Atlas becomes a near-perfect archive of the history of worlds outside our solar system. For planetary scientists, 3I Atlas resembles a solitary time capsule suspended in the cosmic void, a pristine record of ancient environments in a long-lost planetary system. And the revelations persist. As the object nears the outer planets of our solar system, slight alterations in its orbit unveil that 3I Atlas's mass is significantly greater than its surface brightness would suggest, a sign not only of its size, but also of its unusual density. The implications are profound. 3I Atlas is no mere spongy comet, but rather a colossal fragment of a giant planet. Its combination of rock, metal, and ice mirrors the structures of icy moons such as Ganymede or Titan, like a lost relative that had the chance to evolve into a planet before being torn from its star. Confirming such a dense interstellar object would necessitate a wholesale revision of classical planetary dynamics. All existing simulations suggested that fragments larger than a few tens of miles would remain bound by gravity, unless extraordinary forces intervened. But 3I Atlas, spanning hundreds of miles, could only have been expelled by a cataclysmic event. The most plausible scenario involves a chaotic stellar nursery where young stars form in denser clusters, where close encounters could dismantle entire planetary systems, casting infant planets and protoplanets into interstellar exile. In this context, 3I Atlas could be the remnant of a cosmic calamity, bearing the marks of a tumultuous past. Webb's ongoing observations reveal more enigmas. The object's light curve shifts periodically, reflecting the rugged topography of mountains, basins, and deep fissures. Infrared images display glints from steep ice cliffs glimmering as the object rotates slowly in the faint sunlight. These formations appear to capture a geological moment, frozen in time, with cracks created by tidal interactions or collisions long past now motionless amidst the interstellar expanse. Each rotation of 3I Atlas thus becomes a static map of disaster, a panorama of alien terrain flawlessly preserved over millions of years of wandering through space. The unveiling of these geological features also illuminates how interstellar objects might influence youthful planetary systems. If a body like 3I Atlas were to traverse a protoplanetary disk, it could serve as a catalyst for planet formation, seeding nascent worlds with heavy elements and complex molecules. The potential for cross-contamination between chemical or even biological systems has emerged as a pivotal topic among astrobiologists. The notion that interstellar voyagers could connect the chemical domains of various stars redefines the perception of the galaxy, making it seem less isolated and much more interconnected. Each such object serves as an envoy, not merely from another system, but from a vast cosmic network of material exchanges spanning across light years. As data from telescopes amassed, astronomers began constructing intricate computer models to theorize how 3I Atlas may have formed. One prevailing scenario envisioned a young planetary system with a gas giant orbiting its star. The passage of nearby stars disrupted the outer realms of the system, scattering moons and protoplanets. One of these objects, roughly the size of a small moon, was caught in the gravitational turmoil and flung into interstellar speeds. Over millions of years, it drifted across the galactic plane until chance alignment brought it into our solar system. In that regard, its arrival was both fortuitous and inevitable, a convergence of cosmic orbits intertwined by the delicate mathematics of gravity. The discovery of 3I Atlas has ignited renewed enthusiasm for locating similar objects. If Webb can extract detailed spectra from such a distant entity, future observatories could potentially map entire populations of interstellar objects. Wide-field infrared surveys might unveil vast fleets of rogue objects that remain nearly imperceptible in interstellar space. Some objects could be temporarily ensnared by star systems, altering orbits, or even colliding with planets. This possibility is reshaping the understanding of planetary safety and cosmic interactions. Of particular interest regarding 3I Atlas is its striking chemical diversity. Spectroscopic analysis reveals not only ice, but also metals like nickel and iron, elements typically found deep within disintegrated bodies. This suggests that 3I Atlas is the remnant of a world that underwent a complete planetary cycle: formation, melting, layering, and ultimately destruction, resulting in its exile into space. It is not merely a drifting rock, but the remnants of a deceased world. When scientists assessed its structure, they discovered the outer layer contained hydrates of clathrates, which trap gases within the crystals, releasing them upon sublimation. These materials may account for the intermittent jets of water observed by Webb. The pressure within 3I Atlas remains considerable, even after millions of years, indicating it is not a lifeless fragment, but a chemically active relic. Now, allow me to direct your attention to an even more baffling aspect that calls for a scientific open mind. We must investigate the tensile strength of this object. If 3I Atlas is indeed a fragment from a planet, its capacity to endure the immense gravitational shearing forces during its ejection is perplexing, as most natural rocks would rupture under such strain. Nevertheless, if we analyze the data regarding its light reflectivity, or albedo, we notice it is remarkably high for a rock, almost matching that of polished metal or synthetic composites. This leads us back to a hypothesis that many are reluctant to entertain. Could it be of artificial origin? Think about remnants from a technological civilization. Just as we dispatch Voyager probes that will outlast our sun, an advanced civilization might have launched megastructures eons ago. If 3I Atlas is a non-functional piece of technology, perhaps a solar cell component or a derelict station, its hollow nature would elucidate the density discrepancies we are observing. A hollow artificial shell would rotate differently from a solid rock, and the tumbling motion we see aligns perfectly with the characteristics of a dysfunctional artificial object. While we search for biological signatures, we must not overlook the technosignatures, the industrial pollution or engineering remnants left by those who preceded us. This is not mere science fiction, it is the logical extension of the Copernican principle. We are not unique, and our technology is likely not one of a kind. The insights gained from 3I Atlas contribute to a broader objective: decoding planetary diversity. While exoplanets offer theoretical models, interstellar visitors like 3I Atlas provide tangible evidence. They are traveling specimens from other star systems, granting scientists direct access to materials that are otherwise unattainable. The immense size of 3I Atlas also implies a possibly larger population of rogue planets. If massive objects spanning hundreds of miles can traverse interstellar space, there could be gas planetary cores, icy planets, or even entire civilizations adrift in perpetual darkness. 3I Atlas may just be the initial sign of a vast population that astronomers are apenas beginning to uncover. Spectroscopic analysis by Webb has yielded detailed thermal maps indicating small hotspots on the surface, localized warm areas suggesting that energy persists within, even at temperatures near absolute zero. These pockets of heat imply that slow chemical or geothermal processes could endure for millions of years. This raises a crucial question: are interstellar wanderers as entirely lifeless as previously assumed? The cultural and philosophical implications of 3I Atlas are equally significant. The image of a fragment older than the sun, silently, traversing our cosmic neighborhood, has captured public imagination. It epitomizes the continuity of matter and time, a reminder that the galaxy's history is inscribed in every atom within our bodies and in every speck of dust on Earth. It encapsulates a narrative far more ancient than humanity itself. In capturing its faint light, the Webb telescope effectively captured history itself, a history inscribed in frozen rock and carbon, quietly drifting through space. The object has now emerged as a new benchmark for future missions. Plans have commenced for potential interceptor missions that could examine similar objects up close. A probe traveling at astounding speeds might one day collect samples from an interstellar traveler, enabling laboratory analysis of alien material. Thanks to its sizable dimensions, 3A Atlas serves as an ideal test case for developing orbits and recovery technologies capable of managing such encounters. While its present trajectory lies beyond practical reach, it continues to inspire a new breed of interstellar exploration missions. Here's the vital lesson we should glean from 3I Atlas. We often envision our solar system akin to a secure, closed house. Yet in truth, the windows remain open. The universe constantly hurls bricks, letters, and perhaps even messages through those windows. We must cultivate humility and curiosity, for the next object we discover might not merely be a rock, but a greeting. If this exploration of cosmic mysteries piqued your interest, please like and subscribe to our channel. Also, share your thoughts in the comments. Do you believe 3I Atlas is just a defunct planet, or could it be something artificially constructed? We'd love to hear your theories. Thank you for watching, and see you next time.